problem in section 4.7, the part B of it. Now the part A, if you recall, was pretty easy. Did you go back and look at it? You know, we were talking about finding the area of the largest isosceles triangle, and we wanted to write it as a function of h. And we, you know, just going back and looking at this, we see that we've got triangle ADC, and then we actually, h is this little piece down here, and so we had to identify the altitude, the altitude of the triangle ADC as 4 plus h. And we had B down here, so of course we'd have twice that for the base of the larger ADC triangle, and so we had to go back and identify that as square root of 16 minus h squared. And once we have that in place, we want to maximize the area. We got area in terms of h, and then it's just a matter of taking the derivative of this, finding out what possible extrema. How do you find possible extrema? By setting first derivative equal to 0. Okay. We don't know if if that extrema is a maximum or a minimum, but we can use the second derivative test then. How? Yeah, so take the second derivative. Actually, if we set the second derivative equal to 0, Lindsay, we end up with what? Possible. Yeah, and we're not really looking for those. We're looking for maximizing this. So if we have the second derivative of this function into the second derivative, yes. And then if the second derivative at those points is positive, we know that the curve is concave up, which means that that extrema is a minimum. And if the second derivative with the zeros of the first derivative put in are second derivative is positive, we know, or negative, we know it's concave down, which means that that would indicate a maximum. Okay, just a little review of that. So we take a look at this one, and this says do the same problem, but solve it by writing the area as a function of alpha, and alpha is the angle up here. Okay, so we went through and we said, okay, we're going to let this be C, and in order to use alpha, the angle, we're going to have to get into our trig. So we're going to have to use sine, cosine, tangent, whatever. And we said, okay, we can write C as, what did we come up with? 32, or C squared is 32 plus 8h. And we found C, we could simplify C to the square root of that, so we can find an expression for C in terms of h. But that's not where we're trying to go. We want to write the area in terms of alpha, and we can redefine C in terms of h, but that again. Okay, so we go down and let's see, tangent of alpha. We know tangent is opposite divided by adjacent, and so okay, so we multiply both sides by 4 plus h, and we end up, and the reason we did that is because in the area formula we have a base. And if B is the same thing as 16 minus h squared, is it minus or plus? It's minus, right? I thought we had an error there, but it's minus. Then we can take 16 minus h squared in our area formula and replace it with this quantity instead. So that's what this is all about. We have two of those bases, and so that's why the 1/2 goes away, because we have two of those. But now we have 4 plus h tangent alpha times 4 plus h. So this would be the 1/2 base, and then this would be the height we're talking about. Okay, so then we get down to this. We're still with an h in there, and we have then the cosine of this angle. See, cosine is adjacent divided by hypotenuse. So the cosine of that angle is 4 plus h. Did I have that correctly? Cosine is, yeah, adjacent divided by hypotenuse. Okay, so 4 plus h divided by, and this is supposed to be our hypotenuse. Did we get that up there? Remember we got it, came up here and said c is equal to this. So we have that happening. And then, let's see, that left us with square root of 8 cosine alpha is a square root of 4 plus h. And if you go back now, I'm going to highlight this in green. If we go back to this piece right here, we can substitute that for every place we have 4 plus square root of 4 plus h. And so that would go in for that. And so we end up with let's see here. How do we go to the fourth power? Okay, so because if I squared, I just get 4 plus h, and so if I take it to the fourth power, I would end up with 4 plus h quantity squared here. Okay, so I end up with area can be computed in this manner in terms of alpha. Now, the question is, got all that done. Now I have to do all the work, right? The work being, take the derivative, find the extrema, a possible extrema, find the second derivative, and then put that into. As a little bit of a review here, let's go through and let's see, I was just checking my notes to see if I had anything different. What I have here, you can see if you agree, I have 64 cosine alpha to the fourth power, so we can put that right there, tangent alpha. Where did the 64 come from? Yeah, if I square the square root, I get 8, and then I square it again, I get my 64. Okay, that might make it a little easier. So go ahead and take the derivative of that. If I agree with my answer, you gotten that far yet? Go back and do that. Okay, so we have possible extrema at this point. So now we have to do what? Take the second derivative. Okay, anyone have that done? Give you a moment. Okay, so looking at this, that should also be 0 because everything has a cosine in it. Okay, so the only hope we have is our pi divided by 6. Now, pi divided by 6 has a terminal side right there, or in the first quadrant. So what do you think about cosine x? Positive or negative? Positive. Sine x is going to be positive also. So I've got 64. This is a -2 times something times, what is the sine of cosine x? We just had that, didn't we? 1/2. Because we're talking about the triangle that has 30 degrees up here. This is 1, this is 2. So this is going to be 1/2, and this is going to be square root of 3. Regardless, it's going to be positive. Okay, -8. Now the only thing is, are these negatives going to far exceed what we get over here with this one? So we end up with -8. That's going to be a negative quantity. So that's going to be 1/2. I'm sorry, not 1/2. Let's get this correct. It's sine. So that's going to be the square root of 3 divided by 2 cubed times 1/2 plus 8 times 1/2 cubed times the square root of 3 divided by 2. So the question is, are these negatives going to dominate? Is it going to be positive or negative? I don't know. Do you guys know? Offhand? So we would find out, put that in. So let's go ahead and put that in. If you can read my chicken scratching here, or do your own. But come up with what this, yeah, Brandon? Do I have them backwards? If I have pi divided by 6, that's my 30-degree angle. So sine, I did that, didn't I? Thank you, Brandon. I was not thinking clearly, obviously. So, well, this one won't make any difference. So all we have to do is just reassign our exponents here. Okay. Thank you. Okay. Anyone else want to verify that? Is it negative? Negative. Are we glad that it's negative? Yeah, I'm thrilled. Okay, so maximum area occurs when alpha equals pi divided by 6, which is the same thing, that's radians, same thing as 30 degrees. Now, it says, though, let's go back. The whole thing said find the area. Have we found the area? We found the angle that determines the area, but if we're going to find the area, we'd have to go back to this one. So if alpha equals pi divided by 6, did we say, I mean, I'm confused, 6, my notes are different. Okay, then area of pi divided by 6 equals, and we'd have to go back and compute that. Got it? Long problem. What would we have to do? We had to pay attention to the fact that it says as a function of alpha. I knew someone was going to ask me that. On the test, you know, I am tempted